Hello, and welcome back to Modern Software Management, modsoftman.com on the web, at modsoftman on YouTube. Today I want to do one in a series of talks that carry on from episode 6, where I introduced you to the Horizon Plan. There's a spreadsheet that I put together that I use when I manage my software projects. I've made it available on my website, modsoftman.com, for you to freely download and adapt it to your own needs. I explained it overall in some detail, but now I'd like to go and dive into individual parts of it and do some quicker, shorter types of talks around the various smaller aspects of it. Before we get into it, I just wanted to explain to you my logo. My logo has the quantities N and T and F on it. F, the big F, represents the sum of all the effort that went into doing the features in a release. So that's F. I use little f to be individual, like F sub I to be individual features. And the sum of those, F sub i's, is big F, which is all of the ideal days, so 8 ideal hours, that went into coding all those features. N is the average developer power that was deployed per workday throughout the horizon. So remember, I discussed previously how we look at each individual developer and we ask, well, how many ideal hours per workday on average have you done across this horizon plan? N is just the sum of all of those things, which I call W for work factor. N is the sum of all of those things. And then there's the quantity T. And T is the number of work days where people actually worked by definition during that horizon plan. I have what I call the capacity constraint. The capacity constraint is F is equal to N times T. When you measure it as you go along, and now you're at the end of your horizon, and you look back retrospectively, you will magically find that F is precisely equal to that quantity N times T. And it's not hard to see why. Say you have a fine-grained tracking system that can record the number of hours spent per developer per day on each of the features and nothing else. Well, every one of those little elements of time is going to find its way, of course, to F, of course, because you were working on a feature, but it's also going to indirectly find its way into N, because it was time spent by a developer. So if you're careful about how you define things, this will be precisely equal after you've finished your horizon, right? Oh, it won't be approximately equal. It won't be near equal. It has to be, by definition, be precisely equal. That will only happen if you, as I say, if you carefully define your terms, carefully define exactly what you're measuring, how you compute the quantity N after the fact, then this will be true. When you're looking at it in advance and you're trying to predict things, there's two stochastic quantities, two things that you're predicting that you don't know the exact value of them. One of them is the estimated effort it will take to do all the features. So say you estimate that to be around 400 effective coder days. But of course, that's an estimate, so it's subject to uncertainty. And so that's what I mean by this little dashed area. It wobbles. It could be bigger or it could be smaller. It's about 400. The other stochastic quantity is this quantity over here called N. N is the average number of ideal days per workday during that horizon. And we're making an estimate of that in advance as well. So N could also be a little bit stochastic in that it could wobble up and down depending on, say, someone gets unexpectedly ill and N will drop by a little bit, because that effect gets spread over the 40 days, or some people are distracted by other things, an unusually high number of incidents from the field, and they can't work on these features as much. So N is a stochastic quantity, and it will vibrate as well. The way you look at T is you count the number of work days from the start of your horizon to the end of your horizon. So you obviously subtract out weekends when you don't expect people to work. You subtract out statutory holidays. You might have certain company days. We're taking the whole company to a sales conference for 2 days. So you know that in advance, so you take that away. And then that's the number of work days in your horizon. So it's very fixed. It's not a stochastic quantity at all. But you may ask, well, what happens if suddenly the power goes out and we send everyone home for a day? It changed, right? It was 40, now it's 39. No, I'd say it's still 40 by the definition of T, which is a non-stochastic quantity. And the fact that people couldn't work that day will be reflected in the N, the slightly lower N, because that one missing day will get amortized across the entire plan. And again, you say, oh, well, that's wrong. That sounds wrong. It's not a matter of right or wrong. It's just a matter of definition. And I'm just defining things so that T is not stochastic. So anything that you might think might be an error in estimating T actually just goes into N instead. So it's a non-stochastic sort of quantity. T, however, it's a planning parameter. When you come up with your plan, you adjust T to what you want it to be, because you want to try to fit F into N times T. And you compromise. You generally, what your estimate of N is pretty much fixed, but maybe you could hire more people and train them up, or transfer more people in who already know your code, for instance. So F is certainly something that you can decide on how many features and what's the scope of the features at any given time. So you iterate between extending and pulling back T and making F bigger and making F smaller when you're trying to come up with a plan. But like I say, T is a planning parameter. It's not stochastic. T is what it is. It only changes when you decide to change the plan. So these N and Fs, when I say that they're stochastic, and like I indicate this with this bit of fuzziness, the fuzziness isn't a definitional fuzziness, right? The definitions of those things are quite clear. I tell you exactly how to measure them so that by the end of the plan, this capacity constraint holds precisely. There's no fuzziness about it in the postmortem. This equation will be exactly true. The fuzziness is when I'm trying to predict in advance what F and N are going to be, there's a little bit of uncertainty in my prediction. But any of those uncertainties, say a developer quits the team and your estimated N equals 10 suddenly goes down to an estimated N equals 9 halfway through. Well, after the fact, when you measure what N actually was, it'll be like 9.5, something like that, because that developer left halfway through, for instance. But like I say, there's no fuzziness in N and F after the fact. The only fuzziness, you're predicting it in advance. So if we go back to our horizon plan, and here it is again, and again, I refer you back to episode 6, it's got a number of sections to it. So the first section, it has the dates of the horizon. It then has an estimate of the capacity. That's kind of N. That's that's N is that I'm talking about, and we actually come up with an N, and the N estimated is 10.1 is my estimate of what N is for the remaining work days in this horizon plan. So that's 10 effective coders per day across a team of about 30 coders here. The lower part of the plan down here in this area is the F. So these are the little f's I was telling you about, and the summation is the big F. So that's the estimate of the remaining features, an estimate of the daily capacity. So that's N, that's F. And then T is defined up here in the date section of the plan. Let me zoom in. So the first one is, what is the plan start date? So in this case, just in this example, the date is April 4th, 2022. When is the end of my planned horizon? The end of the planned horizon is November 24th, 2022. When the date as at we've updated this plan last was October 3rd, 2022. Just take those dates with me for now. What I do is I count up the number of workdays between April 4th and October 3rd. And that number, you can see over here how it's computed. We use the Excel function called net workdays from B5, which is April 4th to October 3rd, taking into account the holiday schedule. So net workdays already subtracts Saturdays and Sundays, and you add in a bunch of additional holidays as well. And similarly, so that's the calendar workdays done to date. The calendar workdays remaining is, again, from B7 to B9, taking into account the holidays. One is subtracted because you have to assume that when you're on October 3rd, you're talking about the beginning of the day or at the end of the day. So I'm assuming end of day, October 3rd is the as at. So that's why you basically add one here. Or you don't add one, you just compute it normally. That's what net workdays does. And you have to subtract one on this end of things as well. And if we look at the holiday schedule over here, net workdays just uses this array in here. I've just named that range holidays. And you can say we've got statutory holidays like Good Friday, then we have Company Day, we give everyone the day off, Victoria Day, another company day, Canada Day, another company day, and so on and so forth. So T in this particular plan is 157. So the Horizon plan is 157 work days long, and that's what I've set it up to be at the beginning. Now, if this were kind of a SaaS Horizon plan, you'd pick these dates to be a convenient planning cycle, like you'd maybe make it a 6-month cycle, and you'd list in the feature section all of the features that I'm hoping to ship over that 6-month period. And of course, they can get shipped to production at any time during that entire timing, and that's a secondary detail. I think you do need to plan that as well. But at the highest level of detail, we're not looking at that at this time here. It's typically what executives are, less interested in the precise details of when this will be released or that'll be released, or things then like generally what are we accomplishing over the next 6 months. And so that's kind of the beginning and the end of it for more SaaS type, more continuous delivery, or every 2 weeks or maybe monthly ships to production is just incorporated in here. What I've elided over here, let me just unhide these guys, those two. This is what a Horizon plan would look like if you're shipping enterprise software that is to be installed on premises. You'll typically, and that software will be installed in many different environments. There'll be many different upgrade paths to get to that. It'll run on many different types of hardware, many types of virtual infrastructure, a whole bunch of things that needs to be tested. And typically the release cycles are a lot longer because the customers aren't willing to take these upgrades that frequently for enterprise software, because the big project on their end to upgrade enterprise software, it's an expensive thing, it's a big thing on their end. They're not willing to do it that often. Sure, they'd love features more frequently, but they have to have a big process to deploy mission critical software, and it's not worth their while to do it constantly. One of the advantages of SaaS software is you get that feature evolution very quickly. On-Prem enterprise, there's so much overhead just on the customer side. Forget about software vendor side. There is overhead there as well, but there's a lot of overhead, and that we could kind of solve by working hard enough at that. But it's really, there's a lot of overhead on the customer side, and they don't want to take releases that frequently. The overheads on the software vendor side is the developers typically develop in a single environment, and our nightly pipelines run in a single environment. But then we have to deploy it into potentially hundreds of different environments with dozens of different upgrade paths to get there, and all of that needs to be tested. more extensively as well. So we add some extra days on the end, which I divided into a stabilization and a final validation phase, where we find all the bugs in those other environments and things like that. And then we have a final time set aside to run the complete validation test stem to gudgeon. And then we have our final ship date for that software as well. But how do you come up with these 2 dates? Well, this second one, the 20 days, 20 work days, is fixed. It's just a fixed 20 that gets tacked onto the end before the final end date. The 79, however, the 79 is computed by the total work days done plus the work days remaining. That's the 121 plus the 36 divided by 2. So we have a 2-to-1 ratio of coding days to stabilization days. How do you come up with 2-to-1? Well, you do that based on experience. You've had several release cycles of this specific software with all of its stabilization and testing requirements with this specific team. And you've done that in the past, and you've made previous estimates at this, and you found that you weren't ready to ship on time. So therefore you increase those days. Or if you set it to be too big and you found that you had really reached no significant blocking defects much earlier, then next time around you can decrease that. So in this particular example, we've kind of evolved into a 2-to-1 ratio of coding days to stabilization days. And as I say, in the world of SaaS software, people are thinking, what is that? Why have that? Enterprise software is different, or shrink-wrapped, shipped commercial software. I don't know if there is any of that anymore. But enterprise software is different, that you have to run in so many different environments, so many different configurations, so many different point features to test, so many things that can go wrong in that process, that it typically needs a fairly long stabilization time. It's the nature. Hey, if we didn't need it, we wouldn't have it. And absolutely, if we did a better job during the coding phase, then we'd come out completely defect-free at the end with every contingency decided upon and figured out already, and we wouldn't need that much time, and that would be grand. And of course, we keep trying to improve our processes so that this can get smaller and smaller. But the point is, don't just set a goal. Like, our goal is going to be, we're going to divide this by, 4 instead. A manager can't go set that and say, guys, that's your goal, make it happen. They're already trying hard to make sure that they don't have bugs. And they're doing regular integrations, and they're doing testing pipelines throughout the whole thing. But it's just very complex enterprise software with so many different use cases that can go potentially wrong, that history has shown that if you change that to divide by 4, you're just going to miss your end date, right? That's all there is to it. So I agree. If you can demonstrate in a release cycle that you can use less time than what's allocated here, then by all means, at that point, say, yeah, it didn't, that would be a better thing now. So if I change that, you can see I pulled my date into March 8th as a result, because this date here is computed basically by just starting at the end of development and then adding the 52 plus the final 20, taking into account holidays and coming up with, what is the work day that's at the end of that. So why is it a ratio? Because it's silly that it's not a ratio. Right? If you do more and more work, and the more work you do, the more the software changes, the more defects are injected into it during that change, you're obviously going to need more time to stabilize it, not less. There's a huge mistake that if this phase takes longer and you slip the November 24th date, the managers are bound and determined to keep the April 17th date the same. And it's just magical thinking, because you actually spent a lot more time wrecking the software, wrecking it. Model developers as defect injection machines. Yes, they also inject cool new features, but at the same time as they're doing that, they're definitely injecting defects as well. So this defect injection machine has been working for longer. It's going to take longer to stabilize it according to that ratio. It makes no sense that if you hold this date steady, therefore this 79 would go down and down and down and down as the November 24th slips. There's magical thinking saying, well, it was way more complex than we thought to get it done, but no problem. The testing's just going to go really good. That's ridiculous magical thinking, of course. So that's why the ratio. And that's why if you slip this date, if you're in trouble with this date, you have to slip this by a bit, then you're also going to have to slip this 79 as well. So you can kind of see how that works. So if I change this date, for instance, by almost say a week to 12/1, we can see our April 17 date goes out, kind of makes sense. You got the slip, and then you got that slip divided by 2, and you have to add those two things together. And that's your new date at the end of the day. These two dates between November and April, they don't really play into the Horizon Plan at all. All the action in the Horizon Plan happens in this period of time. That's what I'm tracking. And at the target end of development, I should be feature complete, and all the developers should be quite confident in the features that they've coded at that point, and we should be done. And there's only this long tail where we need to validate that software and fix any remaining integration issues. And often all the developers their first priority is to work on this release during this period of time. However, even though it's their first priorities, there's a lot of, that doesn't take a lot of time. It's more time for the QA team, the developers. They might, add some extra automated tests in, or they might start working on pre-work for the next release of the software during that time as well. It's just a bit of a buffer zone to make sure when your software goes out, it goes out with absolute perfect stability under all of the possible install scenarios. Next time, what I plan on doing is I'll go back and talk about the N side and the F side and other aspects of that plan in more detail. I'll see you later.